Hello friends, in this lecture I will be telling you that what are two-dimensional arrays. So in case of one-dimensional array, so the numbers are arranged in such a way that a single index can work. For example, if I want to fetch, let's say this array is having 5, 6, 9, 2 as the element, so this is A array. Okay, then if I want to fetch the 9 from here, then only one index, that is 0, 1, 2. So 2 will give me this 9. So I can work with single index. So that's why it is also written as AI, or in programming AI. Whereas if to fetch an element I require minimum of two indices, then for that then that particular type of array is called as a two-dimensional array. So you have observed that whenever you visit any library, so outside that particular library, you will be seeing one rack like this. And in this particular rack, you can place your books, your laptop, your bag, etc. before entering the library. So let's say this is the portion where I've kept my book. Okay, then if this index is j and this is I, that is, this is zeroth column, this is first column, second column, third column, sorry, zeroth row, first row, second row, and third row, and this is zeroth column, first column, second column, and third column, then where is my book? It is in the second row and 0, 1, 2, second column. So the index of my book is 2, 2. Okay, let's say I have kept my bag here. What is the index of my bag? It is in the zeroth row and third column. So it is 0, 3. Okay, got the point or not? So in this way, you can fetch any element placed inside this rack in a similar way. There are cases, and the best example is your matrix, where you can see that the numbers are lying in rows and columns. So, for that matter, one-dimensional array will not at all work. Then you will be requiring two-dimensional arrays. So, whenever you come across this type of arrangement of numbers, the best way to deal with is two-dimensional array. Let's say 256, 719, 112. Okay, so these are rows, that is zeroth row, first row, second row. These are columns, zeroth column, first column, and second column. Okay, now to define or declare a two-dimensional array in C, you have to use two parentheses, two square bracket. So if this is a two-dimensional, then this two brackets will be required. So in the first bracket, you will be telling the number of rows, and in the second bracket, you will be telling the number of columns. So here, 3 rows are there, 3 columns are there. So 3, 3. So that is how you declare, let's say it is an integer. So that is how you declare a two-dimensional array. Now, how to supply the elements? This is one way. That is, first you write flower bracket, and then inside the flower bracket another flower bracket with all the entries of a particular column. Let's say all the entries of a particular row, that is zeroth row. So it is 2, 5, 6. Then comes the first row, that is 7, 1, 9. Then comes the second row, that is the last row, 1, 1, 2. Close it and close all. So this is a two-dimensional array. You can also observe that how many flower brackets are opening or closing at the end. So they are 2. So this is a 2D array. Now apart from this, what you can also do is you can write the same thing like this also: 2, 5, 6, 7, 1, 9, 1, 1, 2. Okay, so you can write like this. But how? Because this particular system is so smart that it will take this, it will look here. How many columns are there? 3, so it will break it from here. It will break it from here. So now this becomes 3 rows. In principle, inside the memory, the elements, though it looks like a rectangular arrangement of rows and columns, but inside the memory, this will be stored sequentially in a row. Like if this is 2, let's say the address is 200, then the next one, that is 5, will be having address 204 because integer take 4 bytes, so this will be occupying 4 bytes. Then 6, so this is 208. Then 7, so 212. Then 1, 216, and so on. Got the point or not? So it is always stored sequentially. Now, one more thing. As in case of one-dimensional array, here only one index is needed because there is only one row or one column. Whereas in two-dimensional array, two rows and two columns are there. So you will be requiring two loops. One loop for the rows and one loop for the columns. So this is 0, 1, 2 column, this is 0, 1, 2 row. So I want to know what is any I comma j. So that is 0 comma 0, 0 comma 1, 0 comma 2, then 1 comma 0, 1 comma 1, 1 comma 2, 2 comma 0, 2 comma 1, 2 comma 2. So here you have used two loops. Why? Because for I0, I less than 3, I plus plus, and then inside for J0, J less than 3, J plus plus. Now what is happening? For every I, that is for 0, let's say, you are moving in columns 3 times, 0, 1, 2. And then comes next row. For next row, that is row number 1, you are moving in column 3 times. So that's why for I is equal to 0, this loop, this inner loop will run 3 times. Then I got incremented from 0 to 1. So again it will run 3 times and so on. So let us head to the program editor and see what I mean by this. So first thing first, I'm having an array, let's say integer type array A, which is a two-dimensional array. So let's say it is having two rows and two columns. First, let us try to print all the memory location, the addresses. So for int I is equal to 0, I is less than 2 here, and then I plus plus. Then inside this loop, I require another loop for int j is equal to 0, j is less than 2, and then j plus plus. And what I want to do is, now I want to print the address. Now address is an integer. Remember always, it is an unsigned integer. So that's why we will be using percentage %u as the format specifier. So comma, what has to come here? So the address of this a I comma j should come here, and then give one space so that you can understand more better the output. Okay, and then after this row gets completed, you shift to next row, but to new line while printing. So printf and then backslash n. That's it. If you run this, you will be able to see four different addresses. So the first address is starting, let us focus on the last two digits. So it is 16, it is having 16. So 16 plus 4 become 20, and then 20 plus 4 become 24, and then 24 plus 4 become 28. So in this way, what I discussed is, so sequentially it normally comes. So it has come sequentially. Okay, got the point or not? So it always stores, or it always preserves the space for an array in a sequential order, though it's look like a two-dimensional. So let us again move and let us try to print those indices. So percentage %d and then comma percentage %d in first, you are printing what? You are printing I, in second you are printing J, and then there should be some space. So now you can see the first location is 0, comma 0, that is 0th row, 0th column, then 0th row, first column. Then comes next, as we are only having two columns, so then it will come to next. First row, 0th column, first row, first column, and in this way it works. Okay, if you want more, then you can increase the number to 4 for better understanding. So this will be 4 and this will also be 4. Okay, now it is looking good. 0th row, 0, 1, 2, 3 column. First row, 0, 1, 2, 3 column, and so on. Okay, now to transfer elements, again reduce the number to transfer elements. So how can that be done? I can do this, comma, no, comma, that's it. So in the first row, let's say it is 1 and 7. In the second row, let's say it is 4 and 2. And let us print these elements. So they are, so there will be a single element at a location, so that's why only 1% is D. And then we are printing what? Printing AI, comma J, what is there in that location. Okay, so, something is wrong. Oh, 4. So it should be 2 because 2 rows and 2 columns are there. So in the first location, in the first row, the columns are 1 and 7, and in the second row, the columns are 4 and 2. So that's what you have got. Okay, so now that is how you can print it, and even the operations you can do. Let's say this is my array, and what I want to get an array in which the elements are squared up. Squared up means if I am having 1, so 1 square will come there, then in the next column the 7 square will come, and so on. So let us use that power function, power, and we want to do what? We want to square this. Do I have used math? Yes. And let us run it. So it is saying 0. Why? Why it is saying 0? Because power function always return an integer. So let us make it float, and now you can get. Sorry, the power function always return float. So percentage d will return a wrong result. So it has to be percentage f. So 1 square is 1, 7 square is 49, 4 square is 16, and 2 square is 4, and that's it. So apart from this, I've also said that it doesn't matter. You can also write array like this in a sequence. What it will do is it will take this as first row, this as second row, and so on. So if you run it, again the same result. So that's all for this particular video. In this video, we have learned that what is a two-dimensional array, how to define it, how to declare it, how to initialize it, and how to use indices to move around the different elements of this array, and so on. So in this video, till this point only, in the next video, what we'll be doing is we will be working on some problems so that we can understand how to handle a two-dimensional array. So thank you very much for watching the video.